And we're live, so welcome back. We've got another free response question today from 2009, dealing with kinematics this time. So we're dealing with momentum acceleration of an object when we're given a function of energy in terms of its displacement. We've got this 3 kilogram object that's moving along the x-axis, such that its potential energy is given by the potential energy at any displacement is equal to 4 times the displacement squared. U is in joules, x is in meters. When the object passes the point at negative 50 meters for its displacement, the velocity is 2 meters per second, and all forces acting on the object are conservative. First, I want you to tell me the total mechanical energy on the object.
So there is potential gravitational energy and kinetic energy.
So we're moving on the x-axis, so it's probably not gravitational
Or
energy,
just
but there is...
kinetic.
Right. Okay, so we've got all of our energy is equal to potential plus kinetic. Okay, what's my potential energy?
4x squared.
What's the kinetic energy?
Half mv squared.
Okay, so we can substitute.
So 4x squared plus... Oh, we have x? Minus 0.5 square mass is 3 and 2 square.
Okay, so we can simplify.
Square in front of half.
Oh, right.
So
Thanks.
that's 1.
Okay.
1 plus 4 to 6. So 7.
And what are my units?
Joules.
Awesome. Okay. So we need to calculate any x coordinates where we have 0 kinetic energy. What do you think I would have to do?
So when there is no 0 kinetic energy, it means there is no potential energy.
Sorry, say it again. When there is no...
So potential energy.
When there's no potential energy, then all the energy has to be kinetic, right?
Yeah, so 7 is equal to half mv squared.
We were told... So, the opposite, actually. Right now, we have no kinetic energy.
Oh, no kinetic. So 7 is... Yeah, I was kind of confused because if we have kinetic, then there is no x coordinate. Yeah, so 7 is equal to 4x squared, and then we find x.
Okay, you're right, but I'm going to go back one step, so I got to write general forms. What you're really doing is saying what?
So total kinetic energy is equal to potential energy.
The total kinetic energy is 0.
Oh, total mechanical energy.
Okay, total mechanical energy is equal to just the what?
Potential energy.
Only the potential
U.
energy. Okay, if we have no kinetic energy. Okay.
So 7 is equal to 4x squared. So that's gonna be square root 7 over 4.
Close.
Oh, square root.
Close. This is displacement, so not just root 7 over 4.
Huh?
If I solve for x right now, what's going to happen?
Square root. No, I mean root 7/4.
Okay, I'm going to divide this out. This will be x squared is 7/4. After my next
Yeah.
step, what happens?
Root 7/4. Root 7/2.
There should be two answers, not one.
Or plus minus.
Okay, plus or minus. I'll do root 7/2, but either way works. Because this is displacement, it's okay for our answer to be negative, so I should have both of these. What are my units?
Okay. Wait. Meter. Yeah, meter.
Meters. Okay, that's good. Then I need to calculate the magnitude of the momentum when the object reaches a displacement of 6 meters.
So momentum is mv. So at 0.6, mass is 3 and velocity, we have to find out from total mechanical energy to find out V.
Okay, so mechanical energy is equal to
7, and that was equal to 4x squared half mv squared plus half mv squared. And then when x is 2, we have to find out v. So 7 is equal to 4 times 0.6 squared plus half times 3 v squared, and then we find out v. And I will
what is
find
x?
out.
What is x right now?
0.6.
Okay, 7 is
and times 2 divided by 3, then square root. So I got 1.93.
okay.
Meter per second.
Okay, I've already cleared it on my end. I got 1.92, but I don't think it's going to make that much of a difference, but let me try one more time. So just check for rounding.
I got 125 actually. No, 1.925.
Oh, okay. Alright, I'm just going to take your word for it. So, 1.93. Then what's going to happen to my momentum?
So 0.3 times 1.93. So that's gonna be 0.579.
What's our mass?
3?
3. Okay.
Oh, 3 times. Yeah, I made mistake. 5.9. 5.79.
Okay, so I'm going to go 5.8. Units?
Kilogram times meter per second.
Awesome. Okay, we're looking good. Last one, we need to figure out the magnitude of the acceleration as it passes through 0.6.
So acceleration. We just divide by mass and time then, but we don't know the time.
Okay, so if I don't know the time, we'll need a different way of getting this. You okay?
Yeah. Oh. No. Oh, okay. I think I got it.
Okay, go for it. What's your approach?
So, from mechanical energy, total mechanical energy,
Okay,
which was 4x squared plus half m v squared, and then we know the velocity 1.93. So if you plug in here, then we get the function in terms of v, and then we derive it.
okay, that'll work. So, from here, let's just go ahead and derive implicitly. So from here, what happens when I derive?
So 0 is equal to 8x plus
Chain rule?
math. What?
Chain rule?
Oh, dx over dt.
Okay, deriving in terms of time, cool. Because we have to get that acceleration, so we need to derive in terms of time. Okay.
Because m is the constant, it's mv.
Okay, mv times
dv over dt.
dv over dt. Okay, cool. Or I could say, if I move this over to the other side,
so minus, or we can multiply by dt first, right?
we could, but we want to solve for acceleration, I thought.
Oh, yeah. So dv, we finding dv over dt.
Right.
So minus 8.
Okay, sorry, second.
So minus 8x dx over dt divided by mv. But we don't know dx over dt.
What is dx over dt?
That's velocity. Oh, it cancels out.
There we go. Okay, so our dv over dt is acceleration. So our
Yeah,
acceleration.
so minus 8x over m,
Okay.
which is minus 8 times 0.6 divided by 3. That's minus 1.6 meter per second square.
Awesome. And that would work. I'm going to show you one more way we could have done that really quick.
Mm-hmm.
That might have been faster, not sure. But so my force is also this, right? If I just want to derive my energy in terms of x.
Mm-hmm.
So if I did that, this would be the negative derivative of my potential energies. That's negative 8x squared. Or negative 8x. So if my force is negative 8x, and my force is mass times acceleration, then negative 8x is ma, and a is negative 8x over m.
Oh. Oh, it's simpler and much easier.
Either way is fine, but it ends up being the same math. But whatever way is faster for you. Either one of those ways would have worked, I think.
Yeah, but I forgot that equation f equals minus d over dx.
So this is my relationship between work and force. If work is the integral of force in terms of x, then that means the derivative of my work in terms of x should be my force, right?
Yep.
That's really what's going on here.
Oh.
Okay. Any questions from anything today?
Nope.
You did really well on that one, so you carried pretty much everything. All right. So I will see you again tomorrow for Calc or Calc BC. And then homework is up on WeChat and Skype for the rest of the free response from 2009. That'll be due on Wednesday.
Okay.
Okay, thank you very much. I'll see you tomorrow.
Bye-bye.
Bye.